सो हाय गाइस, आज का हमारा टॉपिक है मोनोलिथिक वर्सेस माइक्रो सर्विसेज वर्सेस मॉड्यूलर मोनोलिथिक. Basically, these are the type of architecture which are followed. So each of these architecture is made to solve a real world problem. Each have its own use case, each have its own business goal, and each have its own purpose. So let's discuss about them in detail, its benefits, its trade-offs, and which one we should choose. Okay, so let's begin. So first we will talk about monolithic architecture. So what does monolithic architecture mean? Monolithic architecture says one code base, one database, one deployment. So what does this mean? It means when you are making an application with monolithic architecture, it simply says all your services are in a single service, in a single application on a single server. Think it like a giant kitchen as an example, where every chef, all tools or workflow are in a single kitchen. Simple communication, fast acts, everything going in a single kitchen. Okay, application example. So you can say authentication layer, your order, your payment services, your inventory services, your notification services, your database, all are in a single application. These all services here are using a single database as a point of truth, and it is deployed on a single server. So this is what a monolithic architecture looks like. Basically, it tells that your code base, your database, and your deployment, everything's club up to a single unit. It works as a single unit. Okay. So what are advantages and disadvantages of this architecture? Okay. So if we talk about advantages of this architecture, firstly, it is fast to build, test, and deploy. What does it mean? So as it is a single unit, so it's easy to maintain, debug, and test. Why? Because everything it is in a single unit. When you debug, you know the exact flow which the application is flowing. You know exactly which part of application is not working, where we need to scale, what are the actual problem, how data is flowing. It's really easy to debug. The communication between the services are also really fast here. Okay, so simple debugging is covered. Easy asset transaction. As the DB is same, all services mostly are pointing towards a single DB. It's easy to maintain the transaction. It's easy to debug it. Easy to maintain the transaction logs, and easy to retrieve the data from a single point of contact. Okay, no network latency between the components. As everything is deployed on a single server, there is no network latency between the component here. Okay, perfect for early stage startup. Why? Because as it is a single unit, it's easy to develop. For a small team, it's easy to manage the code, as there is no much what we say. There's no much mess of different services, different code base, different database. Everything gets clubbed together, so it's easy for a startup. So, but there are some pain point to it, like tight coupling. So think it like your payment service is broke, but for that single fix you need to deploy a whole application. So if one, that is a big thing, like just for one service you have to deploy the whole application once again. So that's a pain point. Okay, scale entire app for one bottleneck. Similarly, let's say your recommendation engine broke in your e-commerce website. Now because that engine broke, you need to scale the whole application. For that you need to increase the size of it, you need to replicate it, you need to use load balancer for the whole application. Like in monolithic architecture, horizontal scaling is not possible, so you need to scale it vertically. Okay, so that's a major pain point. Then deployment fair, one byte push equal to outage. Because what happens if your one single services goes down, the whole server can get into trouble, because everything again is a single unit. 50 plus devs stepping on each other. What does this mean? So here what it means is, when the team grows, there are lot of services, there are lot of things going on. So when there is a single code base, many developer are writing their code, many will be changing in different services. So in a single unit, it may create chaos. It may be possible two developer or more than two developer made changes to a single code base, which may create conflicts in afterwards. So that are the advantages and disadvantages of monolithic. Now let's move on to our next architecture, which is microservices architecture. So what does it say? It says that each of the service, each of the module which you have in your application should be deployed as an independent unit. What does this mean? So it means that your authentication service, your payment service, your order service, your inventory service, maybe your recommendation engine, your user, they all will be in us independent. They all will be deployed in an independent manner. They will be fully isolated to each other. They will communicate to each other via HTTP methods or queues, or there are different ways to communicate between them. There are APIs which will communicating between them. So this is what microservices architecture says. So what does the benefits, what are the benefits of microservices and what are their disadvantages? Single scale the bottleneck service only. This is the one of the main benefit of microservice architecture. Why? Because you can scale only the service which are needed. Let's say now your uh, recommendation engine is taking a lot of resources, then you can only allocate resource to it. And while your let's say authentication services are not taking that much of load, so you can reduce the resource from there. This is just an example. Simple teams deploy independently, so each team has its own work. It works on their assigned services and they deploy it independently. So just say your payment service goes down, team fix it, team deploy it. There is no effect on other services, no outage for other services. Like user can still browse on your app, can select, can add to cart and make other thing. It's just your payment services which are goes down, which gets down, and you can repair it, and then you can start your services again. Battle fault tolerance, again the same as I explained. Choose different tech stack per service. This is one of the major you can say benefit, as for different services you can choose different tech stack. Like let's say for a recommendation engine you need ML, you can go with Python. Then you can go with Spring Boot, and go for other services where you need multi-threading, where you need better backend support. So there you can go as per your need for different services, while in monolithic it is not possible. Why? Because everything is in a single unit, so you cannot do that. So this is some advantages of microservices architecture. What are hard points? Distributed tracing across 15 services. Let's say there is a bug in your app and you need to debug it. Now it's very difficult for you to identify where the actual bug is coming from, because API communicating from each other from service to service. It's not like that you can debug it across in a single app. You put a debug pointer and just run the app and it will happen. No, as each microservices have its own behavior, its own code base, you need to trace it. Okay, then you need a lot of tech stack along with your microservices architecture other than your code base, like Kubernetes for scaling, service mesh for communication and network, then API gateways for communications. Then there is network latency on every internal call. Why? Because now you are not on a single server, on a single machine, in a single unit. Data is not flowing in a single machine. Now what is happening? There are APIs in between these calls. So what happens with this? When there are APIs in between, one service get calls to another service. In between there is network layer, there are API gateway which communicates to each other for this request and response. So there the time is taken. So there is some network latency in this stage. Then we have saga pattern for cross service transactions. When there is cross service transactions, we need to apply this method. We will understand this in detail in that, but for now you can understand this as you need to apply some method, so that if a single transaction fails, if a single service fail, your all service need to roll back that operation, so that consistency is maintained across the database. You become a cloud infrastructure company. What does this point mean? So basically now you need to maintain a big infrastructure along with your code base. You need to maintain a lot of complex machines, a lot of complex architecture. You need to use a lot of tech just to handle this architecture. Okay, basically what modular monolithic says, each service will have its own clear boundaries, its own clear modules, but they will be deployed on a single server. Okay, so like in microservices, each service is deployed independently. In modular monolithic says you build an app like that. You have separate module for each, you have separate code base, you have separate resources, but these all will be deployed in a single on a single server on a single app. How it will be beneficial? So as there is no different servers, there is no network latency, there is no need to maintain a heavy architecture, there is a no need for you to like what we say, there is no need for you to maintain a random tech stacks and think about much. Okay, now many of you might think how then the scaling will work in this case. So this is not for a stage where you are a big giant, it is for the stage where you are just growing. So rather than shifting directly to microservices, this is a gateway between both of these services, microservices and monolithic. It's modular monolithic where vertical scaling is possible. You can have replicas of your app and put a load balancer to somewhat scaling it horizontally, but it's for basically for more of code maintenance rather than for the scaling purpose. So that's why company loves it, because it gives you monolithic simplicity, clean code, and future flexibility. As I told you, as once you split your code into different services, uh, while you are deploying it into a single server, but later on it will be easy for you to switch to microservices if you want in future. Okay, so if we compare once more, then development speed for monolithic is fast, for modular monolithic is also fast, but for microservices your development speed goes slow. For debugging, again monolithic and modular monolithic is easy, microservices little complex, scaling very poor. Why? Because you only have one single option for scaling it, just vertical. You need to like put resources on your server only, so no other way. More moderate, again same as a single server goes, then there is very less space for scaling. But for microservices it's excellent. Why? Because what happens, you can scale your each service whichever is needed, you can horizontally scale it, you can vertically scale it, you have many options here. Then operational complexity, it's low for the monolithic ones, both monolithic and modular monolithic. It's very high for microservices, because here you need a big team for microservices to handle that, and the other tech stack which come with it to just communicate between the services. Team autonomy, low, high, and moderate. Okay, so what the team autonomy means? So team autonomy basically mean how a team operates. So in monolithic, there is no way that teams are working independently. So it's very low. But in modular monolithic, you get some moderate amount of that, as you have a separate boundaries between the services. So each team work independently. While in microservices, it's totally separate. Like each service is 101% separate from each other. Code organization. So there is no code organization like thing in monolithic, as everything is on a single server. And for microservices and modular monolithic, it's good for both. You should choose and when. Okay, when you are a early stage a startup, you should go for monolithic architecture. Why? Because your priority is to build a service, your priority is to build the application as fast as you can, so you can check whether you are a product market fit and whether you can do it or not, whether your product is working or not. Till here you are not thinking about scale, you do not have a big team, so monolithic architecture you should go. As you grow, you can quickly shift to modular monolithic, where you are a mid-sized company now, you have a little bit grown up team, you don't have that much resources and money to spend on, then you should go for modular monolithic. Once you go big, you have a scaling problem, you need to scale a lot, your organization has grown a lot, you have a big teams, you have hundreds of devs, hundred of tests, hundred of DevOps engineers, then you should go for microservices architecture. So yes, I hope there is no doubt in this video, in this architectural differences between them, when to choose what are disadvantages and advantages. I guess I have covered them all in this short video. So if you have any doubt, you can comment and like and subscribe for more videos.